Hello? 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 Someone on there?
Hello, Simeon.
Yeah. This already passed.
Okay.
It's 5:32.
5:32. Okay.
We have five persons on the waiting room before, but now we have just four. One left. Yeah.
Room.
You said?
Okay, 4. I'm seeing 4 in the waiting room.
Yeah, just 4 persons. So this is the program.
This is what?
Can you view it from your end? Are you seeing my screen?
I'm coming. What did you say if I'm seeing? Let me check.
My screen. Can you see my screen?
Yes, I'm seeing your screen, yes.
Okay. This is the citation of the speaker.
Oh, fantastic.
The program. The Maba membership.
How come we didn't include that? Where would that fall into?
Which of them?
Who will take this membership stuff? This membership stuff you are showing now.
You can still do it now. You just to talk briefly about SPE.
Okay.
About
Okay,
SPE.
no problem. Okay, fine. That's fine.
Then
That's
you
fine.
just talk about this is the training program that is on. Then this is the work for life that is coming. World 9 that is coming. Work for life team, plastic waste to wealth. So that's all. So do we start bringing them in, or you want to wait more? Someone or them? Prof join, but his mic is not, it's not active yet. Hello, Prof, can you hear me? Probably you can log out and log in again so that your mic can be active. Choose the computer audio when joining. Prof, if you can hear me, your mic is not visible. So you can log out, then log in again using a computer audio.
Good evening, everybody.
Good evening.
Good evening.
Evening. Thank you for joining today's section. We started by 5:50. Can we just mute our mic if you're not making any comments?
Good evening.
Our coordinator, where are we?
We'll start by 5:50, 5:50, sir. 3 more minutes to that, Prof.
Okay. It has to be a brief one because we have all been.
Yes, we're trying to catch up one hour maximum, so we can.
We're not going to spend to a brief one. So at you said 5:50 we start.
5:50 we start. Yes.
Okay.
Okay. Okay. Good evening, everybody.
Good evening.
Good evening, everybody.
Good evening.
Good evening, sir.
Good evening, sir.
We let me say a new month to all of us, and for another opportunity to drink from the fountain of knowledge. Today's presentation was carefully selected, sequent to a benefit of many of us here that are not core petroleum engineers because of the accommodation SPE offers to the science family. So this new body, we thought it wise to make sure that we do the needful. So we are starting. That's the agenda on the screen. Before I make my own remark, we have a volunteer pray for us so we can start. It's open for anybody. You can unmute and and pray. A volunteer.
Yes, we are praying. Can you hear me?
In Jesus.
Yes, our Father, we thank you, we bless your name. We commit that day, our our prayer that God, you grant us with knowledge, wisdom, and understanding that whatever we are going to learn, Father, shall be put to good use, a successful flow in our workplaces that we find ourselves, that at the end we shall have the cause to give you glory and honor. In Jesus' name we pray with thanksgiving. Amen.
Amen.
Amen. Thank you so much. Amen.
Amen.
Who prayed? Williams, right?
Yes, please, Emmanuel.
Emmanuel. Thank you so much, Emmanuel, for that.
Not me.
Okay, it's Emmanuel. Okay. So Simeon, just capture the person that prayed, so it will be in our minutes. Okay. So the next we have on the agenda is the YP chairman's remark or the co-chairman. Do we have the YP chairman on the log or the co-chairman? The YP chairperson or the co-chairman?
I think she has not joined yet.
She has not joined. Okay. We're going to skip that. So probably before we end the presentation, they'll come on board. So I'll go straight to reading of the presentation profile of Professor Chibugu Eze. But before I start that, let me thank Prof for being available for us, so we can learn from his experience and his expertise, and through this avenue we can project career values and build competence. Why we come up with this is because of the basis of projecting the core ideas of what we believe in SPE. We are aware that SPE is open to the science class, to the science family. So necessarily, whether you're a petroleum engineer or not, you can be part of what we are doing in SPE, from the geology aspects, from the geophysics, from the mechanical, electrical, and all science disciplines. So we thought it wise to bring information concerning Seismic, the hydrocarbon journey. So many of us, we want to put it on the same page when we talk about petroleum engineering, where the journey starts. So that's why we took it to talk on this topic, and we are very privileged to have Prof here to share his ideas. So you'll be hearing things about when you go for seismic survey, when you go with your vessels down offshore or onshore, how the source rock, the wave, air guns, the hydrophones, the refraction, and all that. We want to give a clue on this so we can project more values when you talk about petroleum engineering. So this is where Prof is an expert in, and we thank him for being available for us today. So please, as Prof gives his presentation with a slide, you can go to the chat box and drop your questions. So Prof will be here to answer your questions. So thank you very much. So I'll start by reading the citation of Professor Chibugu Eze. Professor Chibugu Eze obtained BSc degree in geology in 1982 from the University of Calabar, Cross River State. He obtained a master's degree in applied geophysics from the University of Nigeria, Nsukka, in 1985. In 1987, he joined Rockview Nigeria Limited, a solid mineral exploration company based in Jos, Plateau State, in 1992. He left Rockview Nigeria Limited and joined Western Geophysical, an American oil exploration company based in Port Harcourt, as a quality control seismologist. During his career in Western Geophysical, he participated in the exploration of many of the producing oil blocks in Nigeria today. Still expanding his career, he joined the then River State University of Science and Technology, now River State University, on the rank of Lecturer 1 in 1995. In the year 2000, he obtained a PhD in applied physics and geophysics. He has progressed to the rank of a professor in applied geophysics. Professor Eze has over 50 published research works in both national and international reference journals. He has progressed to the rank of both national and international. Sorry. I'll take that again. He has written 6 books in his field and outside his field. Some of his books include Alternative Energy Resources, with comment on Nigeria position, published by Macmillan Publisher. Sediment and Sedimentary Environment, Compendium of English Expression, co-authored by his wife, and Crisis Management and Conflict Resolution. He has attended many local and international conferences. He's a renowned environmental consultant. He is the founder of a renowned environmental consultancy company, Transparent Earth Nigeria Limited. Professor Chibogubeze is married to Dr. Mrs. Evelyn Eze, a senior lecturer in medical laboratory science at the Rivers State University. They are blessed with children. Can we give a 200 applause for Professor as we welcome him to STEL presentation? Thank you, sir.
Thank you.
Over to you, Prof.
Good evening, everyone.
Good evening.
Good evening, sir.
Is my slide visible?
Yes, I'm seeing your slide.
Yes, please.
Parliamentary Seismic Data Process.
Thank you so much. First of all, we'd like to thank your organization for inviting me. I'm not the one who knows it best, but you just thought I could say something. I just hope that anything I will say can be of use to somebody. Thank you very much. I would also want to say that how I wish this lecture was in series, because when I saw the preliminary seismic data processing, I had to oblige you, but I know that somewhere we may have left the acquisition, because in seismic you acquire, you process, you interpret. Therefore, I would plead with anybody here who is not familiar with the acquisition before we can come to the processing, that I'm sure there will be another day for that. Since we are talking about processing, the first thing is where the data is obtained. Are we obtaining the data from land, from shallow sea, or from the deep sea? The whole of Nigeria as a country has been broken into blocks. What you see that looks yellow, anywhere you say yellow block, is an oil block in Nigeria. Oil block does not mean necessarily that oil has been proven in such a place, but it's likely, and the exploration will go on. So if Nodi also has money, he can buy any of those squares you see, do exploration there, and whatever data is obtained from there, then what we are going to look at today will happen there in the processing. So that is the onshore oil blocks in the country. It goes down from the south and even the extreme north. Then also, if we go away from the onshore, we have the shallow offshore, which you are seeing in blue, and a lot of blocks are there. Then the deep offshore. I want to say here that the big names in the oil industry, which are the oil producing companies, do not do the exploration for themselves by themselves. That for them, what they do is just acquire a block, and then they will need the services of an exploration company, a seismic company. It's a seismic company that goes in there to obtain the data. I would usually ask the young professionals, where do you prefer to work? Is it onshore, shallow offshore, or deep offshore? Maybe Nana Rabi has an answer, or anybody I can see.
Well, personally, I work with a regulatory body, so we regulate the.
Okay. But if you were to go into core acquisition, where would you like to be?
offshore deep.
This
deep
is
water.
this is onshore. This is shallow offshore. This is a deep one.
I will do deep water.
Okay, thank you. Just to because it's interactive. I think I went offshore. I don't remember when last, but I will not want to go again. But that is age. Now, the processing will start right in the field. There are every seismic company, which is an exploration company. Most seismic exploration companies also have data processing company. But before the data gets from the field to the data processing center, a lot of quality control and preliminary processing will go on in the field. Just about 5, and that's what we are going to look at the brief time we have. Now, the oil exploration, the data we get are usually to the refraction and the reflection. For a young professional, first and foremost is to be able to realize, oh, that this is refraction. What I have here is the monitor, which shows you the record you obtain when you take a shot. And why you take a shot is to vibrate the earth. And once you vibrate the earth, the seismic waves will travel down, and eventually when they meet an interface, they will come back to the surface, and a geophone or a hydrophone, as the case may be, will pick it up. It is what is picked up electrically that you can now transform into a hard copy like I have in front of me, and the processing starts here. Like I say, we need to, first of all, look at this and say, is this a refraction monitor, a reflection monitor? I use a red line there to join what is the first break. If you look on top, the lines look straight, but after sometimes they break and be going to wiggle. Now, what I did was to connect the areas, the points at which the break started, the first one. And I was able to join it with a straight line. And if we remember, the equation of refraction in our secondary school is the equation of a straight line. That tells me exactly that this is a refraction monitor. So the kind of information I'll be looking for from this record will be that type of information that is conveyed by a refraction survey. I believe for many of us listening now, this is a routine thing they have had. For many of us, it may not be as familiar. But for those of us who are not so familiar, even if I stop here, I am sure that anybody who looks at the seismic record will be able to say this is a refraction or this is a reflection. If you are able to join the first break, the points of first break with a straight line, that's a refraction. Now, what I have here now, I'm trying to see, is it a refraction or reflection? Now, let's leave the top and come back to where I have the view. And I try to join that, and does not give me a straight line. It gives me something like a hyperbola. If we go and look at the equation of reflection, it's a hyperbola. So that is a reflection monitor, a reflection record, if you like. But on top of it, I use red, and I was able to join those ones straight. What that tells me is that the young professional who goes to do a reflection seismic acquisition also comes back, a part of it is reflection. What are these part of it that is reflection? The one that is close to the source. You are detonating a dynamite in, where do we want to detonate a dynamite in our school? In River State University. Maybe, no, River State University is not, maybe for everybody living in Port Harcourt. we are detonating a dynamite in Rumokoro roundabout, and the receiver is just at Bori Camp Gate, is closed. So that will give us a refraction. But some of them that are in Rumokuta will get the reflection. So I am carrying the two depending on the nearness. But basically, if I take off that stop, I have a refraction monitor. The refraction monitor will give me information on the near surface, but the reflection will give me information from the deep. So far, we have not done much. All we have done is to be able to recognize the two. Now, what I have here is the CDP arrangement. I will explain what I mean by the CDP arrangement. Let's start from the bottom of that diagram so that we'll be able to understand and be able to treat it when we want to do treat the record. Maybe let's look at the other one, the down part of it. I have two arrows and they are meeting at the same place. Now, if I take a shot somewhere with that red cross, and the blue receiver receives it, there is a distance between that red and the blue. I have not assessed every place between the red and the blue. The only place I have assessed is this midpoint between them. Now, if I shift the receiver and shift the source by equal distance, it will still assess that same center. So if you look at all from the beginning to the end, we are assessing the same center. That's the common depth point. And I said here, the common depth point, I said roll on, full spread, roll off. Not to worry, whether you are a petroleum engineer, a geologist, a geophysicist, we will all be on the same page soon. What do I mean by CDP? Common depth point arrangement is taking many, many shots, but sampling the same points. In statistics, you don't just take one sample, analyze, and get your result. So you need to sample one point several times. Now, what is the roll-on? If you have a place like a football field and you want to start from one end of the field, if you look to my left, we want to start this walk from the left, and then we lay the receivers, which are those green, including the blue. I do not have any space to my right to lay because that's the end of the field. I'm just starting. If I take the shots into all of them, I obtain this from what you can see on my left. If you compare it with this one, you can see the center, which is at 60, and you have the records from 60 to 120, and also to the left. So it's balanced, symmetrical. That means I had receiver from that center, equal receivers on both sides. But here, I have receivers only to my left. So any young scientist, the day you start your work, this might be the first type of job you have to do. Is this refraction? Is this reflection? Is this a roll-on? A roll-on means when you are just beginning from the edge of the field. and you have not laid enough geophones to cover that symmetry like this one, maybe you just laid your geophone from 0 to 60. So you will not have any signal from 60 to 120. Can anybody get back to me and say, look, this thing you are saying is rubbish, and or this thing we are saying is making sense?
You are making sense.
Okay, for me, it's making a lot of sense. Yeah.
Okay.
Big sense.
You're making
So,
sense, bro.
the young engineer or young geophysicist or young geoscientist, we have progressed from telling our employer, are we going onshore? Are we going shallow offshore? Are we going deep offshore? We are making sense. And then we get, look at this, 1,000 of this, and look at it. Oh, sir, why is this refraction? Why did you know it's refraction? Because we can join this with a straight line. Then this is reflection. Why is it that the top is refraction? Because they are near offsets. And then how come the first one on the left is not full? Because we have just laid your phone to the left, nothing to the right. But as we progress, we get to the middle of the field, there will be equal space for us to lay the geophones both to the left and to the right. I'm saying left and right of that arrow I drew so badly. You can see the black arrow. Now we have full spread. Full spread, that means if we are using 24 geophones and we decide to lay 12 to the left, 12 to the right of the source, that's what I mean. If your job requires you to lay 360 geophones, unless you have enough space to lay 360 geophones, you have not obtained full spread. Then if you visualize a field, you will be having space in the middle of the field, but as you are going toward the other edge of the field, you don't have enough space again. So you can only lay a fraction of the number of geophones you set out to lay. And it will be a mirror image of the roll-on. Where you are entering is the roll-on. Then the middle, you have full data, full geophones, and that will mean the amount of fold you have. What I mean by fold is just the number of times you're able to sample a point, and then you roll off. And the day of roll-off is always a great day because nobody wants to remain in the bush shooting dynamite. Now, when you have gathered all this, you need to start what I say is a kind of processing. It's not the rigorous processing, but if you don't eliminate these mistakes or point them out, there will be problem as you get to the more sophisticated part. Now, what I said is checking the traces. If you are supposed to use 100 geophones, which means you will have 100 traces, this way goes, that has this useful information. Out of this 100, remember the man that is taking the shot, the recording truck may be in Port Harcourt, but the geophone you planted may be at Umahia. Maybe we wouldn't go as far as that, but at Obibo. So you just assume that the geophones have been planted into the ground. But maybe after planting it, somebody gets angry in this prison hall and use a knife and cut, what is this wire in my palm? And cuts it, and you shoot. And you think you have information, and you don't have information from that particular geophone because it's not brought you any information. Yes, if it is one geophone out of 100, you can still do business. But what of a situation where 80 have been lost? is there anybody in the forum who can tell me how you feel? You set out late 100 geophones because you are not seeing them, and 80 has been caught. Will that give us something good?
Not at all.
Not at all. So the young engineer, the young geoscientist should be able to look at them and say, are all the geophones alive? If you see this one that I put a red arrow on, it does not have the wiggles as the other ones have. So you will pick it as dead geophone. At the end of the day, you work from morning to night, you may say, this shot has, we are to shoot into 360 geophones, but there are 100 dead traces. What is causing this? Then you may have to send somebody to the community where it was laid. Maybe they got angry and told the young boys to disconnect all. And you may have to reshoot it. But in this one I have, even though it looks dirty, but it is just the geophone 316. Can we see the number? Is it visible on your screen?
Yeah, it's 316.
Yes, it is.
If you zoom,
316.
it's visible.
Yeah. Because we are colleagues together, can anybody look around and say, I think this geophone was not behaving like the others? We have started processing. Is there any other geophone
from the chart displayed?
Yes.
From the chart displayed, the 316 is just giving
316 is
like
the only
a
one.
straight line instead of the wavy line. So,
but
yeah,
if you remove 316,
I can see.
There are others also that are not looking as clear as the others. Looking black. Yes. If you look at the lower time section from 3,000 milliseconds down, you will
like
see
311 is looking different.
311
and 331.
311 is carrying a lot of smoke. Am I correct? If I use that word. But our business here is, will our young scientists be able to pick up all the dead traces? I think in my first 1 week as a seismologist, people thought I was doing such a big business in the field, in the houseboat, but I tell you, I was picking dead traces. Now, what else can we pick? We may, I will leave the A wave because we didn't start from acquisition. But in this one, between 378 and 428, can somebody tell me what is happening there? What do you see between the channel? You see the one on top, the first line is short, the middle one is channel, the other one is receiver. Let's use the receivers. Let's use the channel, the middle one. If I'm talking about the middle one, between 378 and 428, no. Do you see any abnormality?
Yes. Like no information is being picked.
What abnormality do you see?
There are no signals.
No reading.
There are no signals. Now, let me compare it. We just saw a bad trace. Let's go back to the bad trace. You see this one I marked here as with red. I called it a dead trace. Please let us see the difference between the dead trace and this one and the ones here. Those ones that didn't receive signal, is there any difference between them and the one I called dead trace? Okay, for us to progress, this one, if you look at it, is not completely stiff. it appears it had the double mind, whether to vibrate or whether not to vibrate. Do you understand? But this one, at the extreme, just straight line. Somebody disconnected this geophone completely, or the young geophone person in the field didn't even bother, because you give people so many geophones to go and plant, and they are heavy. And the young man wants to get money. He say, okay, plant 1,000 geophones. It may not be as many as that. I think sometimes he gets tired and just pass the, have you planted? Yes, sir. Roger. But you see that these geophones, or he plants them and somebody removes them. We are already doing processing. We are eliminating the problems. We are able to see many geophones. Sometimes the geophones that we are not connected will be so many that you say, go back and take that shot again. Now, sometimes they are all connected. Let's start from the left. What, that first circle on my left, what did I call it?
Community activities.
Community activities. You have a line of geophone going from UST through Rumokuta to Rumokoro, and you are sitting in a truck somewhere at my one and saying, take the shot, get it hot, make sure nobody's around the place because of dynamite explosion, and then you know you have all this, but you will not stop somebody in my fault from conducting a funeral activity or any other party. And remember, I said, what you are using to generate a seismic wave that goes down to travel is anything that can vibrate the earth. That's why the dynamite is used. Remember, there was a time people will lift a heavy weight and drop it, anything. So as they are dancing there too, the geophone does not discriminate. They are vibrating the ground in their own part. Can't you see that on that left, even before you get to the point of the signal, there is a lot of confusion?
Yes.
Can we see that point of confusion?
Yes, please.
Yes.
Yeah, and it's happening before 1,000 milliseconds. And you go to the left, there is another thing that is looking different. If you are going from Port Harcourt to Warri, often a time you see cables running around across the road. And these cables might be receiver cables. And you cannot stop the trailer from moving. And by the time you are ready to record, it's the same time the trailer finds it convenient to pass. And your dynamite goes boom, and the trailer makes boom. And your geophones are even closer to the trailer. And you are looking at the right, and then comes, are we having two shots? It looks like three shots. The ones on the left, the main one, which you can see, and then the one on the right. Yeah, the one on the right contributed to the main signal, but even before the vibration arrived to the geophone, the one from your dynamite, I'm using dynamite just as a source here. That's not the only source. Before that one, you have created another source. So in that case, the young scientist is beginning to be able to distinguish between the signal and the noise, because they are noise. In our second stage, someday, if God keeps us alive, we will now see how to start removing this noise, these unwanted things. I don't know where we are because of time. Please, I want us to look at this very well. It is that your energy that travels down to the earth and comes back, the two-way travel part, that gives you an idea of the depth you have to go. Now look at that two black lines up. To my left, the velocity of that layer is 1,700 meters per second. Are we there?
Yes,
sir.
please.
And to my left, it is just 700 meters per second. If I stay on the surface and take a shot, and it goes down, comes up, and I move to the right and goes down, comes up, which one will take a longer time?
The second one.
Are we all together?
Yes, sir.
Yes, please.
We all believe it will take a longer time. But for the young scientist, he's not into the ground. All he's waiting for is, let's assume that is a reservoir. Where is it? The one that took a longer time means it is deeper. Am I correct?
Yes, please.
The one that takes a longer time to come back means it's deeper.
Yes, please.
So, but in the actual geology sense, that structure you are looking for, AB is not, is horizontal, perfectly horizontal. The depth from the left to the right is the same. But your record is showing that it is not the same. Your record is showing that the configuration is A prime, B prime. Am I correct?
Yes, please.
Yes.
Your record is showing that the other end, B, is deeper because it took a longer time. But what actually caused that is the difference in the velocity, lateral difference. Therefore, we must eliminate this difference. Please, if anybody did not understand this, you can talk to me later because we need to be brief in this and go home. I'm almost exhausting my time, but it is very pertinent. Otherwise, you drill past your reservoir. The B is not as deep as it is. This is lateral change in velocity. Sometimes they may have the same velocity, but the thickness is more. If you take a shot from the surface, where will you have longer time? Is it in the where the thickness is small or where the thickness is big, even though they have the same velocity? Somebody should, yeah? We soon finish. I know people are tired because it's night, but can we respond to this one? Where the thickness is small or where the thickness is big, where will you have a greater time?
Where is big?
A longer time when
where the thickness is big. So again, you misinterpret the configuration of AB and see it as an inclined bed, which is not. So in any case, this low velocity layer is a problem. It must always be removed. And sorry, what I have here is blood, but I believe you can see it. So what you do, if you see on the top one, can you see the arrow showing S? Now, what I have here is the dotted line is the end of that low velocity layer that is causing trouble for us. Can you see that?
Okay.
The dotted line.
Dotted line.
Yeah.
Yeah.
Yeah. Now, usually if you go to the one below also, one way of eliminating that troublesome effect we saw, let's take our eyes down to the one below. Can you see S? Can you spot S?
Yes, please.
On the left-hand side, I wrote an S inside something there.
Yes.
Once we cannot see S, we can even close from here. Can we see the S?
Yeah, you can see the S, please.
Now, that is the source hole. The best way to process that with ease is to drill your source depth below the troublesome low velocity layer and bury it so that it does not disturb you. But you are doing that. after what of it, when it is going back to the receiver R, it will still pass the low velocity layer. So you have just reduced your problem by half. Remember, sometimes the low velocity layer will be, what of if it's 100 meters? Are you going to drill 100 meters to prove the dynamite? Therefore, let's go back to one on top. In most cases, the source line, the source depth is within the low velocity layer. So you will always have that depth. Again, can we see here? I think I'm getting to the end. This thing we are seeing that is looking like, is it like a cone? How do I describe it? The signal, who can describe that shape?
Looks like a cone.
Okay. If we use a cone there, we can
just like a
pyramid.
A pyramid or a fitted tank farm.
Okay. So you have seen the effect of the low velocity layer. Another one is because of the far offsets. Like I said, you put a receiver in USC roundabout. You lay geophones to remove that roundabout. You lay other geophones to Borokiri. Those ones that are close to it, we receive normally very fast. But those ones that are very far, after receiving, that's what gives it this shape. So that's why I said effect of far offset. Far offset means the receivers that are very far from where the source of the energy is coming. They create this point, and you must eliminate it. You eliminate it by what is known as linear move out, LMO correction. We will have opportunity of being able to look at this, play around it on the screen and another day. But when you have done that, you bring it to that flat section. It's that flat section that will tell you the true story. Now, when you want to do the linear move out correction, you use the velocity of the low velocity layer. So you are removing two things, the effect of the low velocity layer and the far offset when you do a linear move out correction. I think we stop at linear move out correction because I just wanted to talk for about 10 minutes or thereabout. We do it in stages. We go through about 10 or 12 stages, but this one is what you do in the field. We have not started what you do at the processing center. Thank you.
Okay, thank you so much, Prof.
Yes,
thank you for an engaging presentation, and I believe most young professionals here and members will grab one or two information concerning near signal, far signal, reflection, and refraction. And we know we can talk about geophones no matter from our own side of knowledge and what we gain. So, sir, you said something which I think that we are going to look into, probably on the acquisition aspect. On the acquisition aspect, I think I'm still going to engage you on that if you can come before the move into. So, because laying that foundation will help most people on this presentation to be acquainted with these processes. So, thank you so much. Thank you so much. So, I'm going to look at the chat if we have questions for you, so we can entertain one or two questions. So, if you have any question for Prof, anywhere that is not quite clear, Prof is still here to answer your question and a bit take it offline because we are going to work on timing. And so, probably, can you just drop your question? I made this comment before we started, as we started, that you can go ahead and drop your question. So, I think there's a question here from Engineer Daniel Maduago. Are you there, Prof?
I am.
Let me just read out, or you can still access the chat room. And the question reads, offshore, how can hydrophones be laid on both sides, left and right, of the acquisition vessel? I don't know if you get that question.
I did.
Okay, so we can respond to that.
Thank you so much. I wanted us, I asked where will somebody want to work? If we lump this, we get ourselves entangled. That's why I said if it's possible for us, we will be having it as a series so that we can move from one step to the other. I am on land today. So whatever I showed here is acquisition on land. When we get offshore, we will see the arrangement offshore.
Okay.
How do you know where to map out the oil block? Is it it's through seismic or mere suggestion? Am I correct? Am I reading the correct question?
How do they know? For that, from Achese Williams, how do they know where to map out the oil block?
Thank you so much. The preference is that every sedimentary basin is a potential house for oil. Every sedimentary basin. So, like, for instance, in that of Nigeria, let's see what happens.
Okay, we have another question from. Are you done with that, Prof?
Let me do this. Somebody asked a very important question. How do you know? If you look at this, the first inclusion criteria is sedimentary basin. Sedimentary basin just means places that are not underlain by rock, hard rock. And that's what Nigeria has done. That the places you see white that are not made into blocks, they are not sedimentary basins. But if you come to the sedimentary basins, the deltas have more potentials than every other sedimentary basin. That's why those people who came to explore for oil in Nigeria, first of all, just went to the delta. Now, the blocks you see are arbitrary divisions. The more Nigeria divides it into more blocks, the more money they get. Not completely arbitrary, but not that anybody knows that there is oil here or not. If you buy an oil block, it's an OPL, oil prospecting lease, you go and prospect. In prospecting for oil or any other mineral, you pay the same amount of money you pay for yes, and the same amount you pay for no. The same amount you pay for success is the same amount you pay for failure. When they finish and they tell you that oil is there, you clap. If there is no oil, you can convert it to farm. I don't know what you want to use it for. But if there is oil, then you go back to the government and convert your OPL to OML, oil mining lease, then you are in business. So the thing is just any sedimentary basin. I also wish to say that in present day technology, oil has also been found in the other basement places. And Nigeria may later decide to divide their basement complex into oil blocks. I don't know if I answered the young man's question. The man who answered is not saying anything, so I don't know.
Okay, let's go on with other questions, sir. Can I read? I think the
okay, sir, you answered it correctly, sir. Thank you, sir.
God, thank you so much.
All right, you answered it correctly. Thank you. So much. Yeah, thank you, sir.
Can you read out the other one?
Okay, this is from Daniel. Beside the area of interest and cost, what else can determine the number of geophones required for data acquisition?
Beside the area of
interest and cost, what else can determine the number of geophones required for data acquisition?
primarily the cost and the type of survey you are doing. Today, there are three basic types of seismic survey: 2D, 3D, and 4D.
And 4D.
In 2D, which is just 2 dimension, and that is the type of survey you use where you are not sure that oil is there. You do it, it costs less, you need less geophones just on a straight line. So if you are using 2D, you don't need as many geophones as 3D. But by the time you are coming with 3D, the 2D has suggested to you that you increase your geophones. Now, the number of geophones you will use depends on your fold of interest. What is the fold? Let's put it in the simplest term. Fold means the number of times you want to sample each point. If you use 4 geophones, 2 to the left, 2 to the right, you will only be able to sample a point 4 times. Am I correct?
Sure. Yes, sir.
But if you use 50, 50, you sample it more. So that accuracy, and usually it is the man who gives you the job that suggests to you the number of fold he wants. Then if you finish 3D and the oil well is sunk there and is into production, and you want to use 4D to monitor the oil, in this case, it must be the number of geophones you use for your 3D that you use for the 4D. So 4D, number of geophones that you use in 4D is determined by what you use in 3D. Thank you.
Okay, Prof. I'll just go with just 3 more questions. We have many questions here, so I'll just go through 3 more questions so we can round up these sections. Okay, I'll take another question. Are there adverse effects of blast shots to the plant life or environment? If yes, how is this effect mitigated? I take the question again. Are there adverse effects? Are there adverse effects of blast/shots to the plant life or environment? If yes, how is this effect mitigated?
Okay. The answer is that there is. That is why before you do a seismic survey, you must do the environmental impact assessment to determine the effect this will have. It has other effects, but since we are looking at to plant life, plus to the plant life, I don't know why it restricted it to plant life, but the things that suffer most are the animals. The animals exhibit what is known as avoidance behavior. If you are shooting in a place, the animals will be running away. As they are running away, a hunter the hunter's fortune is running away. And sometimes you could even kill the animal. I'm sorry to say here that sometimes you kill yourself. There was an unfortunate incident where people put dynamite. They didn't know it was under their boat. They wanted to be smart and they detonated it thinking it is far away. They didn't know as they were running, the rope was dragging the dynamite under their boat, and the boat went into the air and the pieces of human beings went into the air. So there are sometimes even yourself, the hearing ability is reduced. But the major one is that it sends the animals away as you're blasting. In the sea, even though I say we are not in the sea today, sometimes if you're not careful, you detonate and you see big fishes floating. Fish is not what you went there to kill, but the shock of the air gun has killed them. Thank you.
Okay, I'll take another one. How do we identify components of hydrocarbon during exploration process?
How
do we identify components of hydrocarbon during exploration process?
You don't identify components of exploration during exploration. You identify that during your processing and interpretation. But mostly, please let's listen to this carefully. The target is not even to identify the hydrocarbon. The main target is to identify the traps. Traps are what make where the oil accumulates, what traps the oil. So the basic target of seismic survey is to identify traps. A trap could be a dome, a trap could be a fault, a trap could be a pinch out, whatever it is. Now, after you have identified the traps, you've done your own. You are not sure even that any hydrocarbon is inside the trap. That is why when you have identified it, the oil producing will now engage drillers to do what exploratory drilling. Wild card, they just go and, oh, there is a trap here, drill into it and see whether there is hydrocarbon. If they drill and there is no hydrocarbon, they say this is a dry well. They go and take some Panadol to bring down their headache. If they drill and there is oil, everybody is going around with champagne if that is what they want. So the target is actually on the on the traps. However, with increase in technology, there is people now know the white spot and the rest of them to differentiate gas and the liquid, and I'm sure there will be a day for that.
Okay, Prof. This will be the last question, and it's from Mike.
Thank you.
Owing from your question on 2D, Prof, is that in an ideal 2D seismic survey, the standard is that acquisition line will be parallel and perpendicular to the actual depth of the structure or trend. Is this actually or perceived? So I don't know if you get the question, sir.
Is this truly actual or perceived? I thought he wanted to say, is this practice?
Exactly, sir.
Yeah.
Okay, is there?
Oil exploration is not like many things we do in Nigeria where anything goes. If you don't pay attention to the minutest details, you bite your finger. So this is done completely because before, if you buy an oil mining prospecting lease, the geologists work very much even before you come to the geophysics to know the direction of the deep. You just, even in your 3D, the direction of the line is also determined by the direction of the deep. If some of us may not know what that deep is, but I believe we have an idea. The deep is where the underground structures are inclined to. So it is.
Thank you, sir.
Thank you. Am I done? Are we done from my end?
Hello, Prof. Are you there?
Yes, I am.
Okay, thank you, sir. Thank you, everybody, for your question. Prof, on the chat there I see some questions that need your attention, but you can take that offline. So, Simeon, please, can you go back and project our agenda?
What you will do is questions that have not been answered, send them to my mail. I will reply to them so that we can share.
Okay, I will just screenshot and...
okay, whichever way you do it.
I'll just screenshot. I think we have so many questions from Dan.
Yeah, that's
I'll
fine.
just screenshot. I'm going to send to you. Okay, Simon, can you project our agenda, please? Thank you, Prof, for a wonderful presentation.
Thank you so much. I just hope anybody did benefit anything.
They did, sir, and we'll bring you back shortly, so we can start from the acquisition too, so it can make more sense to what you shared today. Thank you so much, Prof.
I think the same.
Okay, so I will just go.
I can rise.
You can what?
I can rise and attend to other matters.
No problem, sir.
Thank you so much.
Please, Simon, can you project the SP membership drive, please? Okay, thank you, everybody on this call. It's an opportunity to learn from a competent and experienced professionals and how we can create our values in our different disciplines. This is one of the benefits you get when you're an SPE member. And that's why we are still appealing for most of us that are here that are not yet registered on the SPE platform in Port Harcourt section. We should take this opportunity and grow our career stretch. So this is about SPI. This is who we are, probably a non-profitable organization. Our members are engaged in energy resources development and production. So we are scattered across the globe in 123 countries. And SPs have more members across continents. We can boast of membership of 104,000. So if you come join us today, you add to that number. And it's a platform that shares technical knowledge, leadership knowledge, and we build set of skills in communication and name it. So SPE have a mission. The mission of SPE is to collect, disseminate, exchange technical knowledge, just like what we've learned today, concerning the exploration, development, and production of oil and gas resources and related technologies for the public benefit, and to provide opportunities for professionals to enhance their technical and professional competence. SPE believes in projecting career competence. I can leverage on my own benefit to tell us here today that if you've not joined SPE across the 5 sections in Nigeria, they are free to join, and we welcome you to come join us in Port Harcourt section. So this is what we are and who we are in Port Harcourt section. We are one big family that believes in supporting each other to project career value and build career competence. So you can see how we go this mind to bring seasoned professionals to share from their wealth of experience to make us better young professionals. Port Harcourt section is the second largest in Nigeria. Our coverage is 6 states. We can boast of the highest numbers of student chapter in Nigeria. So that's our membership strength, about 108,145 professional members, and we increase daily. That's the strength of our student membership there. And we are known for our outstanding awards globally. Just to mention a few, just some few weeks ago, we were recognized with the Presidential Award from SPI International as one of the best outstanding sections in the world. That is why Port Harcourt section always set the pace for other sections to follow. So you can see, and 2020 was an amazing year that we won the ALP award. The last time we won that was about 96 years back, but we achieved that this year. Despite the pandemic, we're able to be crowned ambassadorial lecture program champion in the whole world. It's not just Africa, across the continent of the world. And we can thank our young professionals for their volunteerism, our members for their passion, and our amazing student members that keep making us proud across the group. All regional technical discipline award, we are standing in different categories, from the regional award down to the global award, our standing young member award held by our members. So we won 6 during the WAY Award, that's SP Nigeria Council this year. We were privileged that most of our volunteers, both in the distinguished and technical categories, were able to come out with 6 outstanding awards, and that of our student award too. Next slide, please. So these are the benefits of become an SPE member. The SPE Online Education, SPE Connect, the JPT. The JPT covers if you are the E member or the complete member. Now, the difference in this is that the E membership, you have access to your journal of personal technology on a monthly basis electronically, while that of a complete, you have it emailed to you anywhere you are in Port Harcourt. It's hard copy. It's handy, so it should be mailed to you, and you receive it, and you get yourself more acquainted with monthly activities in the oil and gas space and updates. So we have one petrol quiz. You have access to industry largest online technical library. This is one of the places that have helped and modeled me and most of our young professionals. You have SPE give you that access to connect with mentors across globe, join an active community, and you can ask all the questions. Just the way we engage Prof today, there are study groups across SPE platform, that's spi.org, where you can engage non-members. You can talk to, you can choose mentors, and you can engage them privately, and they project and share their own experience. So you can learn from them and be better petroleum engineers or better professionals in any of the departments you are privileged to serve in SPE or in your company. So these are our top 10 reasons why you join SPE. Join more than 124,000 on the brightest minds in the industry. Grow your technical skill at our conferences, workshop, and training courses. Receive discounts on journals, textbooks. So these are the benefits. It's easy for all of us to see. You can still go to the link and get more information. You can enhance your knowledge about how we can get help meet the world energy needs. SPE gives you a platform for continuous development. It gives you the mindset of being trainable and teachable. It brings out the best in you, but you have your own role to play to admit and build passion with this avenue. So membership in the Society of Petroleum Engineers Port Harcourt chapter has so much benefit. And again, I want to inform all of us here that we still have scheduled programs coming up in this year. We still have our Work for Life, we have our award night, because we want most of our senior industry members to be part of what we are doing. So please, you yourself on this call today, be a crusader, be an advocate, and share our flyers in your respective company. When we do electronic media, try to tell your colleagues to come and support what we are doing in SPE Port Harcourt. So we have an upcoming event. Currently, this Work for Life is scheduled for the 5th of December. I'm privileged to be the committee chairman in that category, and we have a theme where we want to work on plastic waste to wealth. So we'll be working down Port Harcourt, picking waste and handing it over to a vendor that will go and recycle, stretch those plastic and transform it to wealth. That is the way SPE Port Harcourt chapter is giving back to the society, and we're putting awareness. So we're going to get an NGO that is involved in waste recycling. They tell people how to even do their sorting of waste when we do the work. And to crown that off, we have the award night started the evening of that day. So come marry with us. Invite your colleagues. We want to have a full industry night, and we can't wait to see you that day. So all this process starts with what? Being a member of SPE. And Chime, can you go back to the upcoming event, the Python training? We have a current Python training going on, sequent to the new leadership of this year, headed by Engineer Badar. And this is amazing. The benefit is massive. The feedback is amazing because of the company is building, because we all know about the new normal and the AI, the artificial intelligence, taking the space, the coding and robotic and all that. So we have a program going on currently. It's a 5-day practical hands-on course, automated reservoir engineering and geosciences with Python. The feedback is amazing. You can still join. I think they had a class today before we came join our monthly technical meeting. For most of us that don't know, the young professional of SPE Port Harcourt chapter, we have our monthly technical meeting every month till this year, exhaust 2021. We'll be having a YP technical series where we get information from industry. one of our drive is SPE is a science family. We are aware that most people here are not acquainted with the operation and activities in the oil and gas industry, from production, from reservoir, from well engineering, from drilling, from HLC. So what we intend doing in this body is to make it a priority, so people that are not core petroleum engineering can have some the basis of what happened in the oil and gas industry. That's why we have to go back to bring in someone that is an expert in seismic acquisition and analysis, and we start the hydrocarbon journey, how we start. We're going to make sure that Prof comes back to tell us on the acquisition aspect, which he has promised, so we can all benefit and link all from there concerning our career projection. So we thank everybody on the call. There's so much we can do. There's so much we can do. Please, when we sell flyers of upcoming event, try to invite and contact for your social media platform. All we do here is about volunteerism. That is honoring volunteerism, and you're learning to be better professionals in your chosen field in the energy space. Thank you. Back to the agenda, please. I don't know if we have the co-YP chair or the YP chairman on the call.
I think she is around.
I've not seen her. I've not seen. They're not on the log. I've not seen.
Oh.
Again, okay. We'll just call on the board chairman to make a comment. I can see this. The section chair is there. Can we just give him? Let him make some remark, please. Thank you, sir. Evening, section chair. We are waiting for you, sir. The section chair is not available. Maybe engaged. Victor, are you there? Victor Anisi. Hello, Victor. Victor, can you take the vote of thanks on behalf of the committee, please? Simeon, are you there? Simeon.
Our TIC chair is on the call. Bright, Abodike.
Okay, okay. Okay, TIC chair, please. Can you just give a remark? TIC chair. Simeon.
Yeah.
I think we are behind time. Can you give a vote of thanks so we can close this out, please?
Okay. Good evening, all. On behalf of the board, I want to say a very big thank you to each and every one of us who have, create time to be part of this technical lecture. Indeed, I want to say thank you. And also, please, I want us to also watch out the media spaces for our upcoming events. We're going to be, moving very fast. So I want each and every one of us to look at the various media space for our all our upcoming events so that you can participate actively, even those that will be, featuring physically and also those that will be doing virtually. Like he has said earlier on, we're having Work for Life starting from on the 4th. The Work for Life will be on the 5th. So I want each and every one of us to be part of us in that event. So thank you very much and do have a blessed night. Thank you. Over to you.
Thank you, Simeon. Let me still thank Engineer Cameo Osabume. Engineer Cameo Osabume. Thank you so much for joining us on this call. Ndukwe, thank you so much. Cosmo Nandi, thank you so much. Joseph Cooker, Maxwell Abaduba, Marian Ozioma, Frank Tabo, Achese Williams, thank you so much. Our section chairman and our TIC chairman, we can't thank you enough. We just want to thank you and say, please, for those of us that are not yet members of SPE, we can catch up and do if you can privately chat me up or I'm available. Simeon is there, so we can start your registration process. Thank you so much. Long time no see, Ndukwe, and my boss, Camille Osabume. Thank you so much. Have a great evening.
Yeah, thank you, everyone.
Yeah, that was a nice outing. Well done.
Thank you, Maxwell.
Yeah.